Okay guys, let's have a review of two of our first types of factoring. This one here is the greatest common factor. Looking for what number, what letter can divide out of all the pieces in your problem. So if we have the 2x and the 6x squared, the 2 and the 6 can both divide by 2. And since they both have an x, we can divide by the smaller amount of x's, so we can divide by 2x. So remember, this is the type where you write the greatest common factor on the outside. And then in a set of parentheses, you write what you have left over after you divide by that greatest common factor. So when we have 2x divided by 2x, anything divided by itself is 1. Over here, we're going to have 6 divided by 2. That's a 3. The positive hasn't changed. And then if we had x squared and we divide by x, we still have 1x left over. Okay? Over here, this one's a little trickier because both of the pieces are negative. And so we want to look at what can we divide these two by. Since they're both negative, I would say let's divide by negative. And 4 is the biggest number that they both divide by. 2 would work, but it wouldn't be the greatest common factor, so it might get in the way of another step. Again, they both have x's, so we'll divide out an x as well. So we're going to write what we divide out, our greatest common factor, out front. And then in the parentheses, we have what's left over. So 4 divided by 4, negative 4 divided by negative 4 will be 1. X squared divided by x, we're going to have 1x left over. Here you have to watch out that negative divided by negative will become positive, so that will be a change to a plus. 12 divided by 4 is 3. So negative 12 divided by negative 4 became positive 3. That's what happened there. And then the x's would cancel out because x divided by itself. All right, our other type of factoring we're going to review quick is the difference of squares. Okay, difference of perfect squares. I'm going to write diff of perfect squares. You can Google those if you don't remember them or you don't have your note packet with you about where we listed out the perfect squares. If we have subtraction of two perfect squares, x squared is a perfect square, minus 81, remember that's going to be 9 times 9, so that's 9 squared. This is the type where we break up into two binomials. We split up the x squared and make it x times x. And then we split up the 9 squared and we put a 9 and a 9. And since it's a negative number, negative 81, one of the 9s had to be positive and one of the 9s had to be negative to make that happen. Okay. Remember that it doesn't have to be x squared in the front. It can be x squared in the back. 64. That's the perfect square of 8. That's 8 times 8, so that's 8 squared. Here, when I split it up, since the 8s are in the front, the 8s will come first. Since the x's are at the back, the x's will be at the back. And since it's the x squared that was negative, then it's 1x that's positive and 1x that's negative to make that happen. Okay, so try out your Delta Math assignment and make sure you remember these types.